Okay, this is AP Free Response 225, questions 4, 5, 6, and 7, rapid fire. As always, no guarantees, just honest attempts. So this first question here, the short answer, we have C through H3OH plus H2CO3, and this is the mixture here. So the first thing is identify the hybridization in the C for this formaldehyde, and it is sp2. There's 1, 2, 3 domains, sp2. No explanation needed, so don't give an explanation. Diagram, so draw a single dashed line to represent a strong hydrogen bonding attraction between methanol and the formaldehyde, and the best one I can find is this one right here. The OH, this H here is going to be attracted to the lone pair in this O, so bam, right there. C, a scientist plans to cool the mixture to form a liquid. Well, it says provide a temperature should be cooled to, so it's got to melt. You have to have both things in a liquid state, so you have to be above 181, and you have to be below the boiling point, so below 254. So anywhere between 181 and 254, just put down any temperature. Make sure you have units on that in Kelvin. And finally, scientist analyzes the mixture after it's cooled and determines that 8.59 grams is present. How much energy to condense that? The molar mass is there, so you're going to take your enthalpy of vaporization. It's also the enthalpy of condensation. Condensation is energy coming out, but as long as you just mention that. So you just take your grams, change the moles, you got that, and then you take your enthalpy of vaporization. So this many moles, well, 37.6 kilojoules for 1 mole. And that gives you about 10.0 kilojoules removed. Okay, number 5. So you have two substances, X and Y. First question, based on Vesper theory, predict geometry around SI. SI has 4 domains, which is sp3, so that is tetrahedral. So just tetrahedral for A. B, student claims that compound Y has a higher boiling point because of London forces. Do you agree or disagree? Well, everything else is pretty much the same. Actually, everything else is exactly the same except for the middle atom, Si versus C. So I would agree with that because, I just wrote down, everything's the same. Si has 14 total electrons, and carbon only has 6 total electrons. Si is more polarizable, has more total electrons, so therefore it's more London forces. C, equimolar mixture. The two compounds is heated when the mixture reaches 82 Celsius, which will have a higher vapor pressure. So if you look at the boiling points, 82, this starts boiling, and Y does not boil yet. So therefore, X will have a higher vapor pressure because X will start to boil, and it's going to cause molecules to be in the gas phase, causing higher vapor pressure. Y will still be in the liquid phase, and so it's not going to be as much vapor pressure. It's mostly staying as a liquid. And then part D, it's heated to 198, 12-liter container, 12.5-liter container. Total pressure is 2.30 atmospheres. How many moles of gas? And just use gas law, PV equals nRT. So N equals PV over RT. Get pressure is 0.30 atmospheres, 12.5 liters. Sorry, 2.30 atmospheres. And gas law constant. Temperature has to be in Kelvin. So multiply that out, and I got 0.744 moles. Okay, number 6. Scientist constructs a galvanic cell. So we got some electrochemistry here. And we got zinc on one side, aluminum on the other side. Zinc increases in mass, aluminum decreases in mass. So A, write the half reaction for oxidation at the anode. So you gotta figure out which one is gonna stay and which one's gonna flip. Since I make more zinc, it's increasing in mass. The zinc reaction stays. The aluminum reaction is gonna flip. So that's gonna be the oxidation, because you lose electrons. So A is this first aluminum goes to Al3 plus 3 electrons. I lose those 3 electrons. That is now oxidation. Write the balanced overall equation. You gotta take this top equation. So you gotta make sure the electrons are balanced out. You need least common multiple, which is 6. So take the top equation, multiply by 3, bottom equation, multiply by 2 after it's flipped, and you get 3Zn 2 plus 2 aluminums goes to 3Zn solid plus 2 aluminums 3 plus. Okay, initially, electrode has a mass of 50 grams. Cell is allowed to run for a period of time and then stop. Which electrode's mass change more? Justify with the calculation. So this one doesn't ask you to actually calculate anything. You just need to figure out which one's gonna have bigger mass change. So for this one, what I did was I just took I just said, well, let's just say 6 moles of electrons are transferred. Now, this is way too many moles of electrons, but I just did a hypothetical calculation because, so if I had 6 moles for that, then, well, for every 2 moles of electrons, 1 mole of zinc is transferred. And so that's would give me 3 moles of zinc. And then if I did the molar mass of that, it's 196.14 grams, which is, of course, the masses are too big, they're crazy, but we can still get an idea here. And then if I did the same 6 moles, well, 3 moles of electrons is 1 mole of aluminum. And if I did the molar mass of aluminum, that only changes by 53 grams. So if I scale this down to whatever moles of electrons, then these numbers are also going to be proportional. And so since zinc's mass changes more with that many moles of electrons, it will also change with regardless number of electrons. So zinc's mass is going to change more than aluminum's. And the final one is standard cell has a cell potential of 0.90. Scientist needs a galvanic cell that produces a greater voltage. This is a table, choose one. Aluminum already is negative 1.66. That's the one that's going to flip. So you need one that's also going to be a negative one, but greater magnitude. And so if you pick this one here, that one will flip to be positive 1.85. And then it says calculate what's the maximum voltage that can be generated under standard conditions. So you just take the bottom one, make it positive 1.85, add it to negative 0.76, and that's 1.09 volts. And then the last question, number 7. So number 7 says, glycolate ion, which acts as a base. Here's the diagram. What is the atom that accepts the proton when it reacts with water? That O right there. Part B. Here's KB. 2.5 molar solution of glycolate is found to have OH negative as 1.3 times 10 to the minus 5. Calculate KB, and then calculate Ka from that. So if you know that OH is this, then this is also going to be the same because these concentrations will be in 1-to-1 ratio. And so I'm going to plug it into here. My molarity, 2.5 molar, is going to go into here. Technically, if you know OH, you should subtract 2.5 minus this, but in the end, it's not really going to make a difference at all. It's too small. So I plug that in, and I got 6.76 times 10 to the minus 11. Ka is Kb times Ka is 1 times 10 to the minus 14. So if you take 1 times 10 to the minus 14, divide by that, you get that for Ka, 0.000148. Or you can take the pKb, which is negative log of that, and then you know that pKa plus pKb is 14. Subtract it, take 10 to the negative 3.83, and you get the same answer. The last part here says, can H3O plus act as a catalyst? Agree or disagree? And I said, I agree, because H3O plus is in as a reactant in step 1, but it's out as a product in step 2. Since there is no H3O plus in the overall reaction, it is not part of the reaction, so therefore it is considered a catalyst. So there you have it. That is all the parts.